So it said 7 parentheses 12 minus r is equal to negative 84. So because we look at the 7 and the 84, these two numbers, 84 is by itself, and this is 7 times the quantity 12 minus r. So since I have times here and 84 is divisible by 7, it's a good idea to divide both sides of the equal sign by 7. That way the 7's cancel out, because it's times 7 and divide by 7, which just makes 1. So now all that's left is the quantity 12 minus r, and the parentheses are no longer needed because we're not multiplying anymore. So I just write 12 minus r is equal to. And then 84 divided by 7 is 12, so I remember that it's negative 12 because there was just one negative sign. Next, I want to keep r here, so that's a negative r, but this is a positive 12. So because it's a plus 12, that means I want to minus 12 on both sides. It's important that I know that I could have also written this as negative r plus 12 because of the commutative property where I can write these in any order. And so that's why it's subtraction. It's really clear to see that I would do subtraction with this plus 12, but not as clear here. So now I have negative r is equal to, these are both negative, so we add them together with the same sign. So that's just going to be negative, and 12 plus 12 is 24. Next, we have negative r, and that means negative 1 times r. So since it's again timesing, we're going to get rid of the timesing with division, and we want to divide by the negative so that it's just r all by itself. These negatives cancel each other out, and I'm just left with r. And here I have a negative divided by a negative, which is a positive 24. Fun. So that one was number 3. And then number 6, this one was very interesting. It said 3 parentheses 2x minus 11 is equal to 3 times the quantity x plus 10. So I added in this times symbol. It's also in this one secretly. We don't have to show it when we're right next to parentheses, and that's because if it was a different operation, let's say it was 3 plus the quantity of x plus 10, we would clearly see this plus sign. So when it's missing, the implication or the hidden understanding is that it's times. So knowing that these are both times and these are both the number 3, I'm thinking of this as really like, let's say it's 3x is equal to 6. Well, that's 3 times x is equal to, and then 6 could be written with a 3. It's 3 times 2. So this is a similar idea to this one, but of course, these are more complex. So here, we both have times by 3, so what I can do is divide by 3 on both sides. And then the 3 here cancels, and the 3 here cancels. So it cancels out on both sides because they're both multiplication. So I'm going to do that same thing here. That cancels out the 3's, and I'm just left with the quantity 2x minus 11, which is 2x minus 11. And then on the other side, I'm left with x plus 10. Now, I didn't have to do that. I could have multiplied this out, but that would have obviously been a lot more work that I don't want to have to do. I'd like to do as least steps as possible. It worked out nice because they were both divisible. If they weren't both divisible, I probably wouldn't have done that. So now I look, oh, there's x here and x here. This is just 1x, but this is 2x. So if we don't see the number, we remember that that's 1. So since there are less here, it would be a positive number if I move them over here. So since it's positive, I subtract on both sides. Don't get confused, that's not division. So these cancel out. That's 0x plus 10 is equal to, and then 2 minus 1 is just 1x minus 11. Great. And then one more step. It's a minus 11, so I get rid of that with plus 11 because I want the x's by themselves. And I get 2x is equal to 21. Nope, x is equal to 21. And that's that, super fun.